Reload. Oh my god. Got a gadget problem there. What's going on with that? Why didn't it load it? Like chapter 2. Fast work. Then PowerPoint files, chapter 2. Go again. Please work. Representing chapter 2. Loading it. Present desktop. So here's what I want. We'll do it this way then. Okay, folks, let's start with chapter 2 then. And so, well, we overviewed both static and dynamic routes last week. So we'll look at static routing, advantages, how you configure, and how you troubleshoot. Those are the kind of 3 general objectives working with routes. Let's go. So, route functionality. We mentioned that routers have the ability to learn about networks. Ways they can do this: either you manually enter into a route table using static routes, but if you ever use this approach, if anything changes on the topology, you need to reconfigure it manually. That requires obviously the skills to do it too. And then there's also dynamically learnt using a particular routing protocol. So this little diagram here, which hopefully you can look at on your own, well, in terms of your NetAcad materials, if you can go inside them. Just explain what's going on in this picture. So we've got here static and default routes. We've got R1 and R2. This is the way out. So what this needs is just a default static route to reach any network it doesn't know about. So it's just saying, like, anything I don't know about, go this way. That's the default route. And router 1 has only 2 networks, so there's 1 and 2 there. Okay, so to reach networks, it just needs, again, 2 static routes to reach those 2. That's inside. Dynamic routing, over here. The way dynamic routing works is it's about advertising. So this will advertise to all its neighbors that this one can reach various networks. R2 will do the same. It will explain to R1 what networks it has also to its neighbor here, which is R1. So why would we use static routing at all, given the overhead on maintenance? Some of the kind of advantages of it are you're very good for a simple topology. Sorry, small business benefit from that. It's more secure. You don't need particularly more resources or expensive technology to do it. And the route to destination is always the same, so it's quite predictable. One of the problems with it is it does require the administrator to get involved if something changes on the topology. It needs more resources, which might mean more expensive devices. And as the network gets bigger, it gets more complex, managing more manual things. So on the flip side, with dynamic routing, generally the complexity is independent of the network size because of the protocols doing all these advertisements and the kind of learning that goes on. It's automatically adapting to changes. It's good for simple and complex topologies. It's not so secure. It uses more CPU, memory and link bandwidth. And the predictability of it just depends on how the topology is designed. So when you're going to use static routes and making a decision, it's for networks that aren't expected to grow massively, and routing to and from something we call a stub network. Now, a stub network is a bit like a dead end, on a road. So you can access it by a single route, and it only has one neighbor. So here is an example of the stub network. It goes here. It's only one switch, one device, one network, and that's it. So one single route to get there, and only one neighbor, which is there. You also would use it to represent a path to any network not found in the routing table. So you can use it as a default. So it's like, anything that doesn't get found in the routing table, go to this instead. So you can get a default static for any other network address. Let's summarize there. Other advantages of it are in terms of applications, why you would use it and where. So we mentioned the two already. It also has this thing called summarizing. Now what you can do with summarization is you can reduce the size of an advertisement by giving a kind of like a wildcard on a network. You can say like the first two parts of it only, and that includes, with a certain prefix, a whole lot of other networks within it too. That's like summarizing a routing table. And also as a backup route for redundancy reasons, in case a primary route link fails. This example here, R2 is configured with a static route to reach this stub network here, 172.168.0/24. No need for a dynamic protocol in such a situation. The default route matches all packets and is used when a packet does not match a specific route in the routing table. Can be dynamically learned or statically configured. And what it uses is this thing called what we call the quad 0, it's 0.0.0/0 as the destination IP4 address. That's the way you kind of say that's everything. Creates a gateway of last resort. Commonly used when connecting a company's edge router to the ISP network. So the ISP connection is often a default static. Does that make sense? Like anything you can't find in the routing table on the internal network, go on the internet. Yeah, that's what it's really saying. And the router has only one route which is connected. It's quite an important feature. Just one router for connection. Now you can summarize multiple routes in a single network address. Okay. Some features of this. Someone look up for me the word contiguous. Give me a dictionary definition of this word. Let's apply it. What does that word mean, contiguous? Someone do a quick Google search for me. Bring up that word on define. Just write the word define contiguous. You search that for me?
Sharing a common border.
Yeah, sharing a... It's good.
Common border.
A common border. Yeah? Anything else?
Let's work together in sequence.
What's the word used?
Next to or touching on another.
Good. Yeah. Next or together in sequence. Sharing a common border and touching. Okay. So, contiguous network, or subnets, refers to a group of networks that are literally touching each other. They can be logically grouped and share the same classful IP addressing scheme, e.g. there's 192.168.1.0 and that one there. Same IP addressing scheme there. So touching each other is generally what's being used here, is that. Multiple static routes must use the same exit interface or next hop. So the output, if you're summarizing something, then it should have the same exit interface or hop. And in this example here, we've got four networks, okay? 172.20.0, 172.21.0, 172.22.0, 172.23.0. And this is representing being able to group all these things together by writing a certain route definition like this. This is how it's done. I mean, the actual calculations require a bit of thinking over. If you see here, this says 172.20.0.0/14. This /14 is borrowing some of the mask to make us span across 20 to 23 in summarization. We also have the idea of a floating static route. This gives a backup path. So if the primary route is not available, you can configure it. Remember we talked about something called admin distance last week. If you give it a high admin distance, trustworthiness, and the primary route, it has the ability to be a backup pathway. So the EIGRP distance example here is 90. If you gave a floating static route with 91 or higher, this will be a backup if EIGRP goes down. Remember, the lower the admin distance, the more trustworthy it is. Yeah. So if it's a really low number, that's like primary, where you're going to go first, and the higher it is, the further down it is in the sequence. So as an example of the static route here, this branch wants to reach the HQ using a private WAN link. If that link fails, they can use a static backup here. Yeah. So you connect to the internet as a backup. If the private WAN, this is like literally something you buy, like a special link that you purchase from a business, like I don't know, Vodafone or whatever nowadays, BT for example, will lease you a line, a special private link. If that fails, you just go on the internet to do it instead as a backup pathway. So configuration of these type of routes. There's a command called IP route, and you give it a network address, a subnet mask, then the next hop IP address, which is a bit after that, and then the exit interface. You can optionally configure the admin distance to override in this command too. And typically this is used to configure, well that's always used for that part there. So these bits and pieces here, this is a standard command to configure a static route. There'll be some practical exercises where you're going to do these now shortly, and you'll be just doing some actual configurations using these particular commands here to get practice with them. Oh, this is so small. I think you're going to need to look at your thing for this, folks. I'll zoom in on it, but you'll need to look at your thing, I think, to get the sense of this. They've squeezed 3 slides on here. So in this example, each router has only entries for directly connected networks. R1 is what they're talking about here. So here's the R1. This is the routes on R1. And if I did show IP route on this particular thing, and I wrote the command begin gateway, this pipe, as I remembered last week, I said this pipe will search through all the listings you get and just give you back whatever contains those keywords. So it says begin gateway, so the word gateway is the first word, it will give you all the bit after that. It's like a shortcut. So you've got the variable subnetting of 172.16.0.0, and the networks we can connect to from here directly are 2.0, 2.1, it's going to be, let's find it, subnetted 2.0, 162, 16.3, which is that one, 16.3.1 and 2.1 are here and here. These are the connected routes. Same configuration here actually. You also will see this sort of idea of a heading and subheading. That's what we call the parent and child relationship on these, so there's something more coming on about that later. And I'm just showing you another couple of commands here. There's a show IP route space pipe include C, which shows you all the directly connected routes. Just some shortcuts if you're doing debugging to find things out. Notice also the interfaces are given to clarify. So 2.0 is via serial 00 on R1. There's a pathway there. There's a line, 000 is there. What does DCE mean, folks? Little question from last week. What does DCE mean?
Dynamic and is not dynamic?
What do I have to do? If you see DC, what do you have to do? What's an extra thing?
The time.
Yeah, time. So if you see DCE, just think clock.
Okay.
Yeah, clock. It means that there's clock line. Clock requires synchronization, timing on both those devices to have routing effective. That means you need to be aware of that if you're doing configuration around it.
Only on the serial networks, correct? On the serial.
Serial lines, correct. Only look for the red zap.
It must be configured.
Yeah. Look for the red zap. I mean, it depends what it's already been set to. It might already be configured by the settings, but you normally would need it before you configure that sort of thing. Clock synchronization. Okay, so 000, that line, that's got me the 1 and the 0 network. And the gigabit Ethernet 0030 is on this line here. Okay, now R1 says it does not have an entry in its routing table for the R3 LAN network. Let's look at the picture here. R1 to R3. In this scenario, this particular pathway is not in the routing table to get to there. The next hop can be identified by things you need to have: next hop IP address, router exit interface, and the next hop IP address and exit interface. How we configure a next hop static route. In this example, we're only going to specify the next hop IP address here. So before the packet gets forwarded on, this is R1 we're configuring, forwarded on, the router must determine the exit interface to use as well. So we've got to say where to configure. So when we're configuring, see some commands there. Some routes have been put into this diagram here. Let's look at this. R1 configuration, IP route 172.16.1.0, subnet mask, and next hop address. Can you see on the picture where that's going to go? 172.16.22. Next hop, right there. Okay. So we're configuring a route for 172.16.1.0, which is here. So to get here, I'm configuring the first line via this next hop address, .2, 172.16.2.2, right there to get to there. To get to 192.168.1.0, let's find it. This is this line over here. 255, again, same subnet mask, and then again the next hop is there. And then to get to 2.0, which is over here, the next hop is also there. Okay, so we just configured to get to these addresses, you must go via this route. That's a next hop static route there. We'll break it down a bit. So there's another example. Okay, so when a packet is destined for 2.0, which is down over here, here's what R1's actually doing step by step. R1 looks for a match and needs to forward packets to 172.16.2.2. Because we have made the next hop static route already, we said this was going to be our next hop place to go. So if I got to solve anything and get anywhere, I must go here first, right? So it's looking for a match. R1 will determine how to reach here first. So how do I get from here to here? Okay. So it searches for 2.2. This address here, second time, yeah. And it says, right, and it matches that particular route is related to the exit interface S00, which is right here on this line. This takes two lookups. First time is like looking for the match to get to there. So it kind of looks that up, and then it searches and finds it to a match to an interface. So this is a recursive lookup. If the exit interface is down, so it hasn't been, like no shutdown has not been run on that particular interface after you configure it, the static route configured with next hop will not be installed in the routing table. You only write no shut, yeah, and then the admin goes, the interface goes up. When that happens, what it's doing is it puts a line normally into that routing table. So if that isn't done, the interface is down or admin down, and those configured routes will not be installed in the routing table. Okay, so that can go wrong if you haven't done that properly. Okay, that last one was next hop static routes. Okay, so let's just separate these out. Next one is a directly connected static route. So use the exit interface to specify next hops, and no other lookups are required. The admin distance of static route is 1. Which is that high or low static? Was that going to be a priority or low priority? This one, folks. Low or high? In priority. If admin is 1. So is that a high priority or a low priority?
It's low.
It's high, yeah, because the number is low. It's the opposite, right? The number is low, therefore the admin distance is very high. So it just shows you the configuration, how this is being done. If you look at the commands involved here, what this is saying is to route to 161.16.1.0, which is up here, go out of this interface. It's direct connections. These are always on interfaces. So go off this interface. Same for 168.1.2, which is over here, and same for 1.2.0 as well. Again, the same exit interface. That's your directly connected static route. Once that's been done, I mean, this is just verified, just do show IP route. Once it's been configured, you'll see here that the direct connections to those networks 1 and 2 are now in the routing table. There's 2 lines there on that. Notice, by the way, it says S here. Yeah? That's that static connection. Okay. Enter some Cisco proprietary stuff. So these are methods. Onto something called the Cisco Express forwarding. We mentioned this last week. Remember that diagram I showed you? Forwarding information bases and those sort of like little diagram of showing you ingress and egress and that terminology. So Cisco Express is default on iOS 12 or later. Gives you a faster lookup. And why? Because it has a type of a cache called a forwarding information base. Not confused with FIB. Not saying this. Interesting language they use. Forwarding. Isn't the word FOB some kind of army word? Yeah, forward operating base. I have it like when you have like a big massive cruise ship with planes on it, and you go there, then you go somewhere else. It's just interesting how they use these acronyms. They're all like similar sounding. Forward information base. It's a copy of a routing table and an adjacency table that includes layer 2 addresses. So it's like a cache. Quick look up. You'll look in the cache, and it will be able to make those fast decisions based on that. It doesn't need a recursive lookup, a double match, to find next hop IP address lookups. But to configure a fully specified static route, not only do you specify the next hop IP address, you also do the exit interface too. So both things are being put in here. So when it's an Ethernet network, it says the fully specified static route is used. With the Cisco Express forwarding, a next hop address could be used instead. I'm going to have a couple of examples. Here's a fully specified static route on R1. Look at the details here. So what we're seeing is the same as what you've seen so far already, but the difference is you have this next hop at the end, which is .2, which is there, and the interface also. There's a Giga01 interface there. So it's very much clearly saying where to go, where to face in one line of command code there. And there's the lookup there with the right answer, showing you the right exit interface. To verify your route, this is the kind of commands to show you've done things right. The sort of commands you would type are show IP route static. That will show you the static routes you've got. Notice that all the S results come back here only. That's a useful way of confirming it. You also can do a particular route. You can say show IP route and give it an IP address. Sorry, I've got to zoom this. Oops. Show IP route to that particular location, 2.1. So 2.1 is there. And what it's giving you just is what the routes are from that point. So the routing entries for that particular pathway saying it's static to 2.2. So that default static route, this one here, commonly used when connecting an edge server, sorry, an edge router to a service provider networks or a stub router. You use a default route when no other routes in the routing table match the destination IP address. Here is an example of a default static root syntax. You're going to see the first